Welcome back. This is your math tutor Naresh. So this is the second video of exponent rules. So let's continue. We're practicing the three rules. So we started rule number 1 and we're going to continue with rule number 1. So what if we have 3 to the 4 times 3 to the 9? So what does that simplify to? So the first thing is, do we have the same basis? Yes. So rule number 1 says when you have same basis, you can add the exponents. So this is going to be 3 to the 4 plus 9, which is 3 to the 13. Okay. So now what about 9 times 9 to the 3 times 9? So again, do we have the same base? Yes, we do. So we can add the exponents. So this will be 9 to the 1 plus 3 plus 1. Remember, these 9s have an exponent of 1. So 1 plus 3 is 4 plus 1 is 5. So this is 9 to the 5. And now what about x squared times b to the 4 times c times b to the 5? So how do we simplify this? So first, identify same basis. So the b are the same basis. The x and c are different. So base x and c, they will get copied as is. It's just the b's that we have to simplify. So I can say, okay, let me copy x squared and let me do the b now. So b to the 4 and b to the 5, so that will be b to the 9 and then times c. So I don't have to write 4 plus 5 and then simplify at the next step. I could if I wanted to, but I don't have to. So 4 plus 5 is 9, so that's b to the 9 and c gets copied and we're done. Okay. So now another example, 10 to the 4 x to the 5 times 10 times x. So here again, identify if we have same bases and we are multiplying, so we can add the exponents. So the same bases are, so the 10 and 10 are the same base. So 10 to the 4 times 10 to the 1, this will be 10 to the 5. And the x and x are also the same basis, so we can we're multiplying, so we can add their exponents. So 5 plus 1 is 6, x to the 6. So that's the answer there. Okay. So now what about if we have negative 12a to the 4 times negative 12a to the 4? So we're multiplying the same bracket, right? So twice. Okay. So we have negative times negative is going to become positive. So it's positive. 12 to the, so 12 is the same base, right? So 12 has an exponent of 1, so does this 12. So this will be 12 to the 2. And now a to the 4 and then a to the 4, the bases are the same. So a to the 4 times a to the 4, we add the exponent, so that's a to the 8, right? So now we can simplify at the next step. 12 squared, remember way back when we learned about the squares? So 12 squared is 144. So 144a to the 8. And notice when I started this question, I saw that right away, that negative 12 times negative 12 will give me positive 144. And then all I have to do is then combine the exponents on the base a. A to the 4 times a to the 4 will give me a to the 8. So, but I chose to do this as in the exponent form, 12 to the 2, because we're working with exponents and I wanted you to see that way of doing it, right? So, but there's nothing wrong. You can go directly from here to this step and you'll get full marks on your quiz, on your test. Alright, so now let's do another example. So we have, let's say, 11x to the 3a times negative 9x a to the 3. So now we're multiplying, right? So we're not just sticking to the same base, we're multiplying whatever expressions were given, whatever terms were given. So we simply, now we can, mix and match everything, because now that we know the three rules, right? So 11 times negative 9, that's going to give me negative 99. Now I have base x, I have base x. So when I multiply same bases, add the exponent. So 3 plus 1 is 4, right? This has an exponent of 1. And then I have a's. So same base. So here I have an exponent of 1. So 1 plus 3 is 4. And we're done. Okay. So now let's do, okay. So what about something like this? So negative 4a to the 11 times negative 14 a to the 10 b to the 2. Okay, so let's multiply. So negative times negative is going to be positive. 4 times 14 is 56. And now we have base a, we have base a. So this is going to be, add the exponent. So 11 plus 10 is 21. So a to the 21. There is no b here, but there is a b term in here. And that just gets copied because there isn't any other same base as b. So that's the answer there. Okay. Now, next example, 8 to the 4 times x to the 3 times 8 to the 3 times x. So some of these, they look weird and they look a bit scary. So 8 to the 4, but we just apply our rules, right? So we have same bases. Base is 8. So here's 8, here's 8. So we add the exponents. 4 plus 3 is 7. And now we have x, which is also a base, and they're the same base in both brackets. So x to the 3 plus 1 is 4. So that's the answer. Do we want you to simplify 8 to the 7? No, leave it as 8 to the 7, because 8 to the 7, you're going to get a huge number. So if you want to give it a try, 8 times 8 is 64, so that's only 2 8s, right? 64 times 8, a big number, times another 8, 7 times, you're going to get a large, really large number. So leave it as is. Okay, next example, we have 2 to the 3 times 3 to the 2. Okay, that looks very simple. Okay, what can we do? We actually can't do anything. So we will say can't be done. Like can't be done, it just means that it's already in the most simplified form. So we can't apply rule number 1 because the bases are different. So the only thing you can do is, since the question will say simplify, you can say 2 to the 3 is 8, right? And then 3 squared is 9. So 8 times 9 is 72. So that's how you can give the answer. The answer is 72. But when I say can't be done, it means exponent rules. So it's the exponent rules that can't be applied because the bases are different. So that's what it means. But if the question said simplify, that's what you would do. 2 to the 3 is 8, 3 squared is 9, 8 times 9 is 72. Alright, now last example. 5 to the 3 times 10 to the 4. And again, I would say the same thing here. So the bases are different, so it can't be done, right? So it can't be done. It just means that the rule can't be applied, right? But if we wanted to simplify this, yes, we can do this. So 5 cubed is 125. 10 to the 4, it's 1 followed by 4 zeros, and then you can multiply 125 with 1 followed by 4 zeros, and that's your answer, right? Okay, so we're done with rule number 1, which was when you multiply with same bases, you add the exponents. So now let's look at some examples using rule number 2. And rule number 2 says when you divide with same bases, you subtract the exponents. Alright, so let's see some examples of rule number 2. So we'll start with rule number 2. So we'll start with something simple. So a to the 5 divided by a to the 2. So for the first couple, I'll write it out. So so we realize that we have the same bases and we're dividing. We subtract the exponents. 5 take away 2, so the answer is a to the 3. Another example, x to the 6 divided by x. So again, recognize we have the same bases, we're dividing, so the second rule applies. So subtract the exponents. 6 take away 1, so it's x to the 5. And now let's try another one. 5 to the 7 divided by 5 to the 6. So recognize we have the same bases in the numerator and the denominator, so we subtract the exponents. 7 take away 6, so that's 5 to the 1, and I'm just going to write it as 5, right? So it's understood that there is an exponent of 1, so the answer there is 5. Now another example, 3 to the 6 divided by 3 to the 3. So recognize we have the same base in the numerator and the denominator, so subtract the exponents. So 6 take away 3 is 3, and we're done. Now 2 to the 15 divided by 2. So we have the same bases, we're dividing, this 2 has an exponent of 1, so subtract the exponents. 15 take away 1 is 14, and we're done. And actually come back here, so 3 to the 3, that's fairly simple to simplify. So 3 cubed is 27, so we can write the final answer as 27. So when you have something like this, 2 to the 14, that's going to give you a really large number. So here we don't expect you to simplify. Down here, yes, we would expect you to simplify. Okay, so now we have b to the 9 divided by b to the 3. So here recognize again we have the same base, so subtract the exponents. 9 take away 3 is 6, so the answer is b to the 6. Alright, so now we have, okay, so let's see, what if we have the same x to the 3 divided by x to the 3? So this is an interesting one. Okay, so right off the bat we can say, well, they cancel each other, right? So if they cancel each other, so that's just 1 over 1. 1 divided by 1 is 1, right? So the answer is 1. So that's the trivial way. So we'll say, okay, it's 1, and you're done, and you'll get full marks. Since we're applying rule number 2, so let's do this using our second rule. So the rule says when you multiply with same bases, you subtract the exponents. So 3 take away 3, right? So 3 take away 3. So what's that? That is x to the 0. And now what is x to the 0? So way back we learned when we introduce exponents. So anything raised to the exponent 0, by definition, the answer is 1. So x to the 0 is 1. And it proves to you that anything raised to the exponent 0 is 1. And this is a perfect example where you can see, okay, you end up canceling the numerator and the denominator, and you get 1. Okay, so now let's do a little bit complex questions. So this was enough to drill, sort of to get familiar with the second rule. Alright, so now let's sort of mix things up. Okay, so what if we have x to the 7c divided by xc? So here recognize that we have same bases, x is here and the c is here. So this would be x to the 7 take away 1, that's 6. And the c's I can actually cancel. So c divided by c, that's 1. So the answer is x to the 6. And again, I could have applied c to the 1 take away 1, which would be c to the 0. And by definition, c to the 0 is 1. 1 times x to the 6 is x to the 6, right? Okay, so now let's look at something like this. 10 to the 4 divided by 5 to the 2. So recognize, do we have or do we not have the same base? We don't. The base here is 10, the base here is 5, so I'm going to say it can't be done, right? So we can't apply the second rule of exponents. So if we wanted to simplify, we could figure out what is 10 to the 4, and then we could figure out what's 5 squared, and then divide the two numbers in the numerator and the denominator, and then we'll have our answer. Right? Okay, so again, what is 2 to the 4 divided by 4 to the 2? Recognize, do we or do we not have the same base? The bases here are different, right? the bases here are different, so we can't, but I could convert 4 into a base 2. So 4 can be rewritten as 2 to the 2, right? So we're getting ahead of ourselves. At this point, if you said can't be done, we'll accept that at this point, because we haven't gone and learned all the rules yet, right? So I'm okay with if you say can't be done at this point, but I'll show it to you anyways. So here's what we can do. So 2 to the 4, copy that for now. So here, this is a 4. I can write that as 2 squared, right? So 2 squared is 4, correct? And I write that exponent on top. There you go, right? So now I can simplify this. I can say numerator is 2 to the 4. What about the denominator? So here I'm actually now applying rule number 3, exponent to an exponent. So this is why I didn't want to get into this here. So 2 to the 2 times 2 is 4. So this is 2 to the 4. And this answer equals 1. So this is what we will expect by the end of this exponent rules lesson, right? But at this point, either one is acceptable. Now let's do this the long way. What's 2 to the 4? So you multiply 2 4 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, right? And what about 4 squared in the denominator? That's also 16. So 16 divided by 16 is 1, right? So you've seen 3 different ways. One is rule number 2 doesn't apply because the bases are different. Now here you've seen, okay, we can convert one of the bases so that we have the same base in the numerator and the denominator, and then we can apply our exponent rules. Or and the third way is you've seen the conventional way, right? Something we learned back in grade 1. Okay. Alright, so now let's do a little bit more complex. 19a to the 5b divide by 2a to the 5b. So here we're dividing. So again, in this question, we're just getting everything. So everything that we know how to divide, we know how to multiply, we know rule number 1 and rule number 2. Right? So you can see all of that in the next 2 or 3 questions that we do. So let's divide. Negative 19 by 2. We can't divide. Okay, so we'll just copy. So negative 19, right, and all over 2. So we copy that. And now I have the same bases here. So same bases here. So I can actually, they cancel each other out. So we have the same exponents. Okay, so these ones cancel. Or I could write a to the 0. Right? Okay, I'll write that, a to the 0. Notice when I subtract, the answer always goes in the numerator. And now the b's, okay, the b's actually also cancel. So it's not so complex. So, or, for the sake of using rule number 2, we can say it's b to the 0. So by definition, this is 1, and that's 1. So the answer is negative 19 over 2. Okay, so now negative 25 a to the 5 divided by negative 15x. So how do we simplify? Do we have the same basis, a and x? No, the bases are different. So there's nothing we can do with a to the 5 over x. That portion will just get copied as is. But we can reduce the 25 and the 15. So negative divided by negative, the answer is going to be positive. We can divide, 5 goes into both of these, right? So 5 goes into 25 5 times, and 5 goes into 15 3 times. So the answer is going to be 5a to the 5 over 3x. So that's the final answer there. Alright, so now let's look at another example. So negative 17x to the 11y over positive 17x to the 10. So here, so negative divided by positive is going to be negative. So, and now 17 divided by 17, so they cancel. And now we have x to the 11 divided by x to the 10. So we have the same base. So this is going to be x to the 1. I don't need to write the 1, exponent of 1. and then y gets copied, because there isn't any other similar base in the numerator or the denominator, the same base as y. Okay, so let's do one more example, and this is the last example. So negative 26a to the 7 over negative 2a to the 6. So negative divided by negative is positive, 26 divided by 2 is 13, and a's, we have the same base, so we can subtract. So 7 take away 6 is 1. So the answer is 13a. So this is where I'm going to stop tutorial 2. I hope you found it useful. If you did, please like or subscribe, and we'll see you in the third video. Thank you for watching.